Let's take a look at a problem from section 9.3 on testing the mean difference for matched pairs or dependent samples. A tourist on vacation at a California beach claims on average that the air temperature is warmer than the water temperature, or in other words, the mean air temperature is greater than the mean water temperature. It can be shown that this means that the mean difference, which is the mean temperature for the air minus the mean temperature for the water, is greater than 0. To test the claim, the tourist goes to the beach at random times during the day for 10 consecutive days and records the air temperature and the water temperature. The temperature is recorded each day in degrees Fahrenheit, and these are shown in the table. Assume these temperatures are normally distributed. That is a requirement for this test. Using a 0.01 level of significance, or alpha is 0.01, test the claim that the average, now that means mean, because technically average can be mean, median, or mode. The average or mean air temperature is warmer than the average water temperature. We set up the subtraction order as follows. The difference is between the air and the water temperature. So that would mean that if the air temperature is greater than the water temperature, these would be positive numbers. And you can see that for the most part there are. Here you can see the Excel equations to perform the difference calculations. You create the formula in this top cell and then copy to the below cells. Claim is that on average the air temperature is warmer than the water temperature, or the mean difference, which is the mean temperature of the air minus the mean temperature of the water, is greater than 0. Since that's a strict inequality, then the claim is the alternate. The null hypothesis is the complement of the alternate hypothesis. The complement is that the mean difference is less than or equal to 0. However, most books will write this as just the mean difference is equal to 0, and this is assumed to be true. Since the alternate is a strict inequality, the alternate tells us where the rejection region is. This is a right tail test. The upper 1% of all values of the test statistic, D bar, will be unusually high, enough to cause rejection of the null hypothesis. These values, the upper 1% of D bars, correspond to the upper 1% of the standardized test statistic. T is D bar minus mu sub D, which is 0, from the null hypothesis, which is assumed to be true, divided by the sample standard deviation divided by the square root of the sample size. The standard deviation of the D bars is sigma D divided by the square root of the sample size. But we do not know sigma D, therefore we must use the sample standard deviation of the differences. That means that our standardized test statistic is not Z, it's T, which is D bar minus mu D, which is 0 from the null, divided by the sample standard deviation of the differences D, divided by the square root of the sample size. Step 4 is to draw the sample. When we do that, we get D bar, which is the sum of the D's, these differences divided by how many there are, is 0.49 degrees Fahrenheit. Here you see the Excel equation that does that calculation. We get that the sample standard deviation of the D's is 1.12 degrees Fahrenheit rounded. And here is the Excel formula that does that. Written out, we see this. This is the same thing. And then we need the standardized test statistic, or the T statistic. D bar is the test statistic. The standardized test statistic is T. So T is D bar minus mu sub D, which is 0 from the null hypothesis, divided by S of D over the square root of the sample size N. We have N is 10 matched pairs. So that's 0.49 degrees Fahrenheit minus 0 degrees Fahrenheit divided by 1.12 degrees Fahrenheit divided by the square root of 10. So we see that that's 1.38 rounded. That's standard deviations from the mean. And here is the Excel formula that does that calculation. Note where the parentheses are for order of operations purposes. It should be noted that while we write with rounded numbers, we don't actually calculate with rounded numbers because that will propagate round-off error. We use Excel for our calculations, and that carries all available digits. It should also be noted that a d-bar of 0.49 supports the alternate hypothesis that mu sub d is greater than 0, which is assumed to be true under the null hypothesis. D-bar is a point estimate for mu sub d, which the hypotheses are about. The only question now is this d-bar of 0.49 degrees Fahrenheit in the upper 1% of all d-bars under the assumption that mu sub d is 0? To find that out, we do step 5, or the p-value, which is the probability that d-bar is greater than 0.49 degrees Fahrenheit under the assumption that mu sub d is 0. When we standardize to t, that becomes a probability that t is greater than 1.38 standard deviations from the mean. Here we can use t.dis.rt for right tail. The first input is 1.38, our t sample, comma, degrees of freedom is sample size 10 minus 1. The calculations are done in Excel as shown here. So here is the value that we get, 0.100 rounded. And this is the Excel formula that does this calculation. Step 6 is to make a decision. To do this, we compare p-value to our alpha level or level of significance. If the p-value is less than alpha, we will reject the null hypothesis. If it is not, we will fail to reject the null hypothesis. These are the only two allowable decisions. So we write p-value of 10%. We write the alpha level of 1%. And then we ask the question, is 10% greater than or less than 1%? 10% is greater than 1%. Therefore, our decision is fail to reject H0. Keep in mind what the null hypothesis says. It says there is no effect. In this case, it doesn't make any difference as far as the temperature is concerned whether or not it's air temperature or water temperature. The alternate hypothesis is there is an effect. In this case, it is that the mean of the air temperatures is greater than the mean of the water temperatures on average. In the decision step, you should consider errors. If you fail to reject the null, you're subject to a type 2 error. This is a false negative, or you failed to reject a false null hypothesis, or you failed to detect an effect that is there. In this case, the effect is that the mean air temperature is greater than the mean water temperature. The final step is to interpret in the context of the scenario presented. There are 8 things that you should touch on to be complete. At a significance level of alpha is 1%. So you always state what it is in words and then provide the symbol. There either is or is not enough evidence. If you fail to reject, there's not enough evidence. So is not enough evidence. 2. 3 is reject or support. If the claim is the null, then the word is reject. In this case, the claim is the alternate, so the word is support. The claim, now talk about the claim. That the, state what it is, mean difference, and then give the symbol, mu sub d. We state the subtraction order as well. Mean of the air temperatures minus the mean of the water temperatures. Now state what the measurement is. This is a continuous random variable. Temperature is continuous. 5 is temperatures. 4, the word is all. The hypotheses are about a population parameter. So 6, water and air talk about the population. This particular location, it could be something different someplace else, is, now talk about the interval that the claim is about, greater than 0. The end.